Hello everyone, welcome to
Hey.
Hands-on AI, where we walk you through AI Lab step by step. I'm Annie,
And I'm Ayo.
and today we're gonna talk about data with capital
A
D.
capital D. It's capital
Yeah,
D.
and as always, this is a two-part series. And in this first episode, we're going to talk about ML in BigQuery to learn an analytical case. And tomorrow, for this episode 2, we're going to play around with RAG in Cloud SQL and also all the way to the index with RAG and build an automate pipeline all the way to RAG agent. And Ayo, like as always, let's start with
Yeah,
equipment
cool.
check.
Yeah, so Andy, you want to walk us through that? So essentially, for this collab, we always recommend that you use a Gmail account. Don't use a corporate or a kind of an educational account. Those tend to have restrictions that kind of
Yep.
limit you as you go through the lab. And after that, make sure that you're on a laptop because we're going to be working in Cloud Shell, which is on the Google Cloud Console. So you want to be able to navigate. So we know a lot of you like to watch this on your phone, but if you want to go through the lab, switch over to your laptop. And then lastly, Andy's going to walk you through how you can redeem credits for the lab. As part of this collab, we're going to be calling models like Gemini and interacting with different Google Cloud services to make sure that you don't have any costs. We give you credits for the lab. So if you want to follow along, just walk through and follow any steps.
Sure, thanks, Ayo. And yeah, I'm currently share the screen of how to claim the credit. You will see a link on the screen to go to this link. Basically, this is the way for you to get free credit so that you have everything set up for today's lab. And you will see a different title here, but you will see a button like click here to access your credit. All you need to do just click the button and just agree and continue. You do not have to put any personal payment information. You will see credit successfully applied. If it asks you to put your personal payment information, that probably means that they want you to sign up the free trial, but it's your choice. You do not have to put personal payment information. And to verify that you successfully claim the credit, you can on the left hand side there's something called credit, and if you go to the credit, you can see that you have this $5 available for this lab. All right. So once you finish claim the credits, you're ready to get started with today's lab. Ayo, why don't you walk us through about what we're gonna cover for today's lab?
Sure. Let me share my screen. So here's an overview of the architecture of what we're going to be building over this 2-day, lab series. So a few things that we're going to be doing is first, we're going to be interacting with GCS, BigQuery, Cloud SQL, data flow to productionize our different workflows. We're going to be deploying a RAG agent to Cloud Run. But for today, for Lab 1, what we're going to cover is we're going to learn how to do ETL with GCS and BigQuery. So how can we convert data, unstructured data that's in cloud storage, use something like Gemini to convert it to structured data that we can use analytics against, like SQL, and then analyze it within BigQuery. So essentially, what we're learning for day 1 is ETL with
Yeah,
Gemini, with BigQuery, with cloud storage.
yeah. So ETL is extraction, loading, and transformation, and you're gonna see those in today's lab
Yep.
and see how we transfer unstructured data to structured data in BigQuery. See the magic here.
Yeah. Yeah. So if you're following along with us, so step number 1 is just like an overview of the agent versus context. So by the end of this 2-day lab series, what we're going to do is fight a boss in the cloud.
Yay.
So it's like a gamified kind of lab. So if you want to learn more about that kind of the agent verse and like the different classes, last week we covered the summoner class. This week we're covering the scholar class. You can kind of look at number 1, number 2, we just walk through the architecture. And then number 3, what we're now going to do is essentially, now that we've redeemed the credits, we want to essentially set up the environment for our project. So we want to make sure that we have an active project, make sure that we're authenticated in our Google Cloud project, enable APIs that we're going to use as part of the lab. So essentially just a setup before we actually dive into the actionable parts of the lab. So bear with us. We're not going to walk through the setup, and then we'll kind of quickly go over to the first step of the lab where we're going to do ETL with GCS, BigQuery, and Gemini. So
Let's do it.
yeah. So going over to step number 3, we're now at preparing the Scholar Sanctum. We've already done the redeem Google Cloud credits. So if you missed that step, make sure that you watch the beginning of the video. Now what we want to do is go to our Google Cloud Console and kind of proceed from there. Okay, so here's the front page of the Google Cloud Console. If you want to navigate to the Google Cloud Shell, you just want to come over here to the top right corner and hover over this icon. You can see Activate Cloud Shell. If you can click the icon, or you can just press G then S on your keyboard. There's two different ways of invoking the Cloud Shell. You're going to be asked to potentially authorize or take you directly to the terminal. Cloud Shell is essentially a remote VM in the cloud that's managed by Google. So it has persistent files. So whatever code you write or files that you save to it, you can come back to it over time, and it'll still be there. There's an editor that's very similar to VS Code. So essentially you can develop Python, whatever languages that you are familiar with directly here in your Google Cloud project. Again, you can save the files. So here's where we're going to be acting and kind of running our commands for the next few minutes. I'm going to zoom in so you can see.
Thank you.
Now that we kind of brought up Cloud Shell. Yeah, sorry, go ahead.
Oh, no, sorry. I just going to add, it's just similar to VS Code on cloud experience.
Yes, yeah. Okay, so going back to the next step of the lab, what we want to first do is do gcloud off list. You just want to make sure that we're authenticated in the Cloud Shell. So you should see an active star and the name of your account. Make sure that this matches the same account that you used to redeem the credits. If you don't see this and you're not authenticated, you can do gcloud auth login, run this command, and then proceed with the gcloud auth list just to make sure that you're authenticated. Okay, so the next command that we're going to run is to clone these two repositories that we're going to be using in this lab.
Yeah, I saw there are two repo. I assume that data engineer is the one we're working on today, and dungeon is the final boss we're going to fight.
Exactly. Yeah, so Agent vs. Data Engineer contains all of the starter code and template files that we're going to be using to kind of make our job a little bit easier. So you don't have to worry about starting from scratch when it comes to building images or writing your RAG agent throughout this lab. Essentially, we provide some starter code, so you don't have to worry about the imports and things like that. The Agent vs. Dungeon has the essentially the image and files that we're going to use to actually build the dungeon where we're going to fight the boss.
Sure.
So we're going to go ahead and build that ahead of time. So by the time we build our RAG agent, it's ready to go. So that's pretty much it. So let's go ahead and clone this here. And I'm going to go back to the terminal.
We want to deploy our boss ahead of the time and while we're continue building our data engineer, so that the time we deploy our data engineer, we have the boss to fight because it's already deployed on Cloud Run and we can talk to the agent through A2A.
Yes. Yeah. So, and next thing we want to do is, so far we have no project yet. So we redeem the credits, but when you're operating in a Google Cloud kind of context, you have to kind of have credits associated with a project. So what we're now going to do is essentially create our starter project that's going to be kind of created for us. So I'm going to go ahead and run this command here, init.she, and it's going to tell us that it's going to enter a project ID that you have in mind, or press enter to use the default Agent vs. Scholar, some sort of random ID. So I'm going to go ahead and use the random ID, and it's going to go ahead and create the project, link the credits that we redeemed earlier to this project, and then do a few other things so we're ready to go. So that may take up to 20 seconds or so. So it's installing the Google Cloud packages that we're going to be using throughout this lab. It linked the credits, as you can see here, and then our billing account is active. So we're good to go, at least for that step of the lab.
Yeah, okay. And you can see the yellow font that point to our current project, making sure this is start with Agentverse, because if you have multiple projects, it might point to a different one. So you need to double check that.
Yeah, that's a really good point. So throughout this lab, you may have to kind of refresh your Google Cloud Shell and your browser. And sometimes you can lose authentication status. If you do, always make sure that you see this yellow kind of ID and your project ID in your terminal. If you don't, you can kind of set your project using gcloud config set project, and then put the name of your project ID, and that makes sure that you're in the right context.
Thank you.
So moving on, the next thing we want to do is essentially just set the project ID for our gcloud config, exactly how I just said. So you just want to make sure that our gcloud has the right context. So that's set. And then moving on, what we now want to do is essentially enable all the APIs in our project that we're going to be using throughout the lab. So in a Google Cloud context, just because you enable APIs doesn't mean that you're going to start being billed for it. But if you want to use certain services, you have to kind of enable the API ahead of time. So for this lab, we're going to be using BigQuery, cloud storage, AI platform for interacting with Gemini models and embedding models, data flow in day 2 for essentially productionizing our RAG pipeline. So essentially, we're just going to go ahead and enable all the APIs that we're going to be using for today and tomorrow. So come back over here. I'll go ahead and run this. And this may take anywhere from 20 to 1 minute, 20 seconds to a minute. So don't worry if you see that it's taking a little bit of time. It does take a little bit of time. So, okay, great. It's finished. Let's move on to the next step.
Yeah. What's the next step?
Okay, so we enabled all the APIs. The next step is to essentially build the empty container image repository that we're going to be using for hosting our image for the dungeon, for hosting the image for the RAG agent later on. So that's the next thing that we want to do.
Yeah, because we containerize our agent, and then we want to deploy the Cloud Run, and then you want a place to host your image. I'm curious, if you want to deploy things to Agent Engine, like you probably don't need this, right? Because you don't need to containerize your agent for Agent Engine. What has AI Agent Engine?
Oh, great question. I believe you still have to containerize your image. But since Vertex AI Agent Engine is a managed service, you don't have to manually manage that step. So when you're using like ADK deploy to Agent Engine, behind the scenes, an image is being created, but essentially it's managed by the Agent Engine process rather than you having to create an image that you then deploy directly to Cloud Run yourself.
Yeah, so it's actually so what has AI Agent Engine take care of those behind the scene?
Exactly, yeah, because it's a managed service as opposed to Cloud Run, which is more of a serverless, where you used to have a lot more control over like the scalability, the kind of the compute associated with each machine. So great. So that finished. Great.
Yeah, thanks for answering. I don't know everything.
No. Okay, so the next thing that we want to do is essentially enable all the IAM permissions that we're going to be associated with our service account. In Google Cloud, pretty much all your actions have some sort of identity. So if it's a Cloud Run machine that's running, that has an inherent service account identity. If it's a BigQuery communicating with GCS, there's some sort of identity behind that. So we want to make sure that the default service account for our project has the ability to, interact with cloud storage, has the ability to interact with BigQuery, has the ability to, create data flow pipelines. So that's what we're essentially doing here, is essentially making sure that our service account for our project has all the permissions that it needs. So I'm going to go ahead and do that here, come back over here to the terminal and run that here.
Yeah, and also we are using the same service account for all the permission, but in production use case, it's recommended that you have a separate service account for separate permission for more security. This is like a demo purpose, so that we're using a single one for easy, so that you can easily follow, right?
Yeah, great point. Separation of principles, and separation of roles is really good practice. So this may take anywhere from 20 to 30 seconds. And as you can kind of see behind the scenes, it's assigning all of the service accounts the necessary IAM roles that they need. And so, okay, so that finished. Moving on, the next thing we want to do is go ahead and, as mentioned before, we want to build our agentverse dungeon ahead of time. So this is where we're going to have the boss fight later on. We're going to go ahead and kind of build it. So build the image, deploy it to Cloud Run, so it's ready by the time we get to that point.
Yeah.
So go ahead and run that here.
So this run cloud build .sh file, basically we want to deploy agentverse dungeon behind the scene, and you can go to Google Cloud Console, Cloud Build to see the progress if you're interested. Because right now it's like running in the background, right?
Yeah, so sometimes when you call Cloud Build, you may notice that it gives you a link directly in the terminal that you can click, and sometimes it's if it's submitted in the background, essentially you can just go directly to Cloud Build in your Google Cloud Console, click the top result, and then make sure that you've selected your project. So I'm going to come over here, select Project, Agentverse Scholar, and then you can actually see that there's an active build going on right now. So this is what we were referring to. So behind the scenes, our image for the dungeon is being created. And then as part of the Cloud Build, YAML for this is going to deploy to Cloud Run once it's done building the image. But overall, this is just so we're doing it ahead of time. So when it's ready, so when we get to that point, But for now, we're done with the setup and we can proceed.
Let's go.
Yeah. So let's proceed with the rest. So as mentioned before, for today, what we're going to learn is how to do unstructured to structured data analytics, leveraging GCS, BigQuery, and Gemini. So it's kind of what?
Sorry. Also, maybe we explain to our audience that what is unstructured data and structured data we want, so that we have better idea of what are each step, like what are we load, what are we transform, because you want to transfer them to structured data, right?
Yeah, great point. So when we say unstructured data, so oftentimes you may be working as a data scientist or as a business kind of personnel. You're working with PDFs daily. You're working with text files daily, Word files. These have a lot of content and insights in them, but essentially there's no way to kind of programmatically in a structured fashion kind of get insights from them. So think about a PDF that has different types of structures. How would you actually have a model do something like SQL analytics against that? It would be very tough. But how could you convert those text files to structured data so then you can then do traditional structured analytics against it, like ranking, ordering of certain information? That's what we're going to learn today. So how can you take text files that are uploaded to GCS, use something like Gemini to convert those text files to extracted JSONs, where you extract all the relevant information from those text files and you sort them and organize them into JSONs. And then from there, we're going to essentially create mini tables out of those JSONs where each key is going to be its own table, like a monsters table, a battles table, adventurers table. Don't worry, we're going to kind of cover all of this later on. So essentially, that's what we're learning. So how can you take text files, convert it to structured data that allows you to do structured analytics against it?
Yeah, so this is a gamified thing. In a real life situation, it can be, for example, you're a researcher, PhD researcher, you want to research multiple article in PDF form. So you have the PDF form in cloud storage bucket. And how do you analyze them with AI or like with your agent, right? So you need to figure out a way to convert all the PDF data. The PDF is just a file data. It's not structured data, right? So we want to figure out a way so that it can be a structured in a structured way, so that AI or our computer can able to analyze it, and you can build program on it. So that's why we want to load the data. We want to like transform this unstructured form to structured form.
Exactly. Yeah. Okay. So proceeding with the lab. You may notice that there's these data engineers notes kind of throughout the codelab, kind of like what Annie just mentioned. This kind of gives you kind of more of a real world context of what we're doing behind the scenes. So while it is a gamified lab, we want to make sure that you understand the real world analogies behind what we're doing. So when we say like structured, unstructured to structured analytics, what is the value of that? And so there's a lot of real world use cases for that. So make sure that if you want to kind of have more of those kind of insights, kind of read those data engineers' notes throughout the lab, but we'll make sure that we explain it as well as we're going through. Okay, so let's proceed. So the first thing we want to do is, as mentioned before, we're going to be storing unstructured text files in GCS. To essentially enable BigQuery to query those files, we want to make sure that we create what's called the BigQuery external table, which has values for various reasons. Oftentimes, in many data analytics use cases, people oftentimes create copies of data between their development, their production, their staging environments. And that creates data governance issues where you have different copies of your data. Now you have different management policies that you have to have for each of those copies. And it becomes more of a headache than you would like. What BigQuery external tables allows you to do is you can leave your data in one place, such as GCS, but create essentially a pointer or symbolic relationship with that particular data in GCS. So you can query it, you can kind of see the text files without you having to move or copy the files. So that's essentially what we're going to be doing in this next step. And
that's so cool.
And that relationship between BigQuery and GCS is mediated by what we call a BigQuery connection. So as mentioned before, everything in Google Cloud has some sort of identity. So BigQuery is going to be reading from GCS. It has to have some sort of service account identity to do that. So essentially, we're going to be creating that service account identity behind the scenes. And then we're going to give that service account identity all the permissions that it needs to read from that GCS bucket.
Let's do it.
Yeah. So let's go ahead and create that BigQuery connection. I'm going to come back over here to the terminal, and then I'll paste that here.
Yeah, this is so much easier because you cannot directly analyzing and transform data in cloud storage, right? And then if you load everything, copy like all the like big chunk like file to BigQuery, that's actually tons of work and it costs a lot and have, as you said, a security issue. And then if you just simply add this connection and have the pointer to it with our external table, that's so much easier. This is like so cool.
Yeah, how can you, and where else could you do massive, petabyte scale transformations without having to copy data and do it, with 10 lines of SQL or so? That's essentially what we're going to be learning as part of this lab. Okay, so we just went ahead and created the connection. And also behind the scenes, it's important to mention that we're also seeding the GCS bucket with all the text files that, we're going to be using for this lab. So we talked about GCS. We have to actually make sure that GCS bucket has some sort of, seeded file so we can actually process it. So there are a few ways to navigate to cloud storage. You can just come over here to cloud storage in the search bar and then select the first option. You can also go to the front page of your Google Cloud Console, and there's a few quick options you can select from as well. So now if you go to your buckets in Google Cloud Storage, you can see that there's two different buckets that have been created so far. One is for the cloud build process. So as mentioned before, we built our image for the Agentverse dungeon. Behind the scenes, there are a few staging files that are associated with that. That's created by default and stored in the cloud build bucket. We also just went ahead and created a reports bucket that has all the historical battle reports that we're going to be processing as part of this lab. So as mentioned before, this is a gamified lab. And essentially what we're storing here in this reports bucket are historical battle reports of adventurers fighting different monsters across different battles. The reason why we're doing this is because we want our Agentverse, we want our RAG agent later on, when it's fighting a particular monster, we want it to be able to leverage insights from past battles to kind of use it when it's fighting, monsters now. So how could you actually leverage insights from past reports so that our RAG agent can kind of use those insights? That's what we're going to be learning now.
Yeah, so if you're curious about how to build RAG agent, don't make sure to check next episode. This is like 2-part series. Just wanna, don't forget to check another one. Oh, sorry, Ayo, please.
No problem. So let's take a look at one of these unstructured files. So scroll fragment log entry for BR734. In the archives of forgotten ideas, a scholar of the Agentverse, Alara, confronted the angelic specter of perfectionism. The entity cataloged as monster ID, shimmered with a life force of 120 hit points. So overall, essentially, these are battle reports of past battles, and we want to kind of leverage these as insights for future battles. So we're going to be learning how to kind of create structured insights from this, and then actually then use this in a SQL context. So that's just the idea of what our text files look like.
Yeah, we want to load this data and transform this to structured data.
Yeah. So next thing we want to do is, so we've now seeded the GCS bucket with all the text files that we're going to be processing. And we've created the connection that's going to serve and mediate the connection between GCS and BigQuery. But we actually have to kind of create that data set in BigQuery that's actually going to be storing kind of all that transformed data. So you have to have some sort of empty repository or empty data set for data to kind of flow into. So we're now going to be using the BQ command is actually creating an empty data set called bestiary data. So coming back over here to the terminal, we now want to run that command.
This is trying to point to this data so that in BigQuery, you can you directly query the data without actually loading all the data, right?
Yeah. So you can see that dataset in Agentverse Scholar Unique ID project, bestiary data has been successfully created. So that's great. And don't worry, we're going to navigate to BigQuery in a second, and you can actually see the empty data set. Okay, so coming back over here, the next thing we want to do is taking that same connection service account that we created earlier. Again, we want to make sure that it has all the permissions that it needs to actually kind of operate how we need it to operate. So this connection service account is mediating the connection between BigQuery and GCS. If we want it to be able to kind of read from the bucket and read the files that we created, we're going to give it the storage object viewer role so it can actually read the files. And also later on, we want it to be able to kind of call Gemini so it can actually do the transformation. So we're also going to give it the AI platform user role. So this allows it to call the AI platform APIs such as Gemini and the embedding models that we're going to be using for day 2. So let's go ahead and do that now. Come back over here to the lab. I'm going to run this here, and it'll take maybe 5 to 10 seconds.
I'm curious, do we have similar connection with like Cloud SQL, with Cloud Bucket?
Great question. So with Cloud SQL, there are ways where you can create representations of data in Cloud SQL and BigQuery. But that's through a slightly different process than an object table.
We will talk about it later.
Yeah. Okay, so next up we want to do is echo the bucket name of what we created earlier. So this is just going to become helpful when we navigate to BigQuery. Later on, you're going to see the prompts for where you're going to insert that bucket name as part of like the commands we're going to be running BigQuery. So just so that it's available and handy, we're going to go ahead and echo that right now so you'd see it. So coming over here, echo bucket name, and you can see that same agent versus scholar unique ID reports that we kind of talked about earlier. So you can kind of go there if you want to find the bucket name, or you can just navigate to cloud storage. And again, it's going to be the agent versus scholar, some sort of unique ID dash reports bucket that you need. So again, so now that we've done that, we're finally going to navigate to BigQuery. So let's go ahead and do that now. So again, there's a few ways you can do it. You can either copy this link here and just put it directly in your browser, or you can just navigate here to your Cloud Shell or Cloud Terminal and put BigQuery in the search and just select the top result. And that will now automatically kind of take you to where you need to be in BigQuery. So for now, I'm going to make this a little bit smaller and we're good to go. So go ahead and open up a new tab in the query editor. And what we now want to do is essentially create that external table that acts as the representation of our GCS to BigQuery connection. So we're going to be reading in the files from that GCS bucket so we can actually then process it later on. So let's go ahead and do that now. So putting that here, create or replace external table, bestiary data, raw intel content table. Essentially, it's a raw text column that we're creating. The file that we're reading is a CSV format. And here's, again, this is why it was relevant for us to echo the bucket name. Make sure that you put the bucket name here. Otherwise, you're going to see an error later on. So let's go ahead and put the accurate bucket name.
Let's put it here.
So that's it. And again, all we're doing is pretty much reading from that bucket and this particular folder and grabbing all the files from that folder.
Yeah, and also this external table is a virtual table, right? It's not a real data.
Exactly, external data. So as mentioned before, when you're creating a BigQuery external table, we're not actually copying the data from BigQuery GCS to BigQuery. We're just creating like essentially a pointer to that GCS pathway. So essentially, it's in real time when you query that table, it's going to be reading those files and the text content from those files in GCS. So it's a really good way of allowing you to kind of combine structured analytical techniques from BigQuery with your unstructured data that you have directly in GCS. So the query has been completed. You can go directly to the table that was created. And now we can see our raw intel content table. So you can see the column that was created, the raw text as we specified. And if you want to query it, which we can do next, you can do preview. So, oops, sorry. Let's skip this. I'll just leave. So as you can see, you have your raw text column that was created and everything's good to go. Later on, we're going to query and see what those contents looks like.
Yeah.
So if you want to actually query that table, what you want to run is select star from bestiary data, raw intel content table, and that will show you essentially the CSV extracted contents directly within BigQuery. So let's go ahead and do that now. And let me make this a little bit bigger and run. So query completed. Let's go ahead and see what it looks like. You can kind of see the column one. Is there any way I can make this a little bit bigger? Maybe I'm zoomed in too much. Okay. So you have the raw text column, number one, number two. So you can see all the raw CSVs that were read. It's being read directly into this raw text column in BigQuery, and we're good to go. Okay, moving forward, what we now want to do is essentially echo our GCS connection kind of string, because later on we're now going to be creating a Gemini connection that's going to be serving as our transformation engine for converting these text files into structured data or JSON information. So let's go ahead and echo that now in the terminal. And here you can see it here, agent versus scholar, US Central 1 GCS connection. So that's just essentially the GCS connection string that we want to keep in mind for later on.
Does it dynamically load? For example, if I upload new things to GCS bucket, does it like?
Oh, great
Because
question.
yeah.
Yeah. So Annie asks, if it does it dynamically, does the BigQuery external table automatically update when you when you add new files to GCS? And it does. So let's say you had 5 files when you created the BigQuery external table. Then the following day you added 25 more files. If you were to query that external table again, the same way that we just did, select star, bStery data or onto a content table, you would see 30 different rows. So
Wow.
it dynamically adjusts based off of the GCS content. So that's what makes it so powerful. And oftentimes in traditional use cases, after you copy the data, whenever you have to kind of update it, you have to update it across all your different environments. But if you have it in one location, essentially you can just update one location and then kind of propagate it to all the external tables or downstream spots that you have. So it's a really powerful way of, again, maintaining proper data governance in a kind of a fluid way.
So to summarize, like whenever I modify bucket, it will automatically reflect in the BigQuery external table. But if I modify external table, it does not affect original data in bucket.
Yes. That's correct. Yes.
Okay, thanks.
Okay, so as mentioned before, so we echoed our connection string, so keep that in mind. And now what we want to do is essentially create that GCS, a BigQuery connection between BigQuery and the Gemini model that we're going to be using for transformation. So as mentioned before, in Google Cloud, everything has some sort of identity. So if we want BigQuery to be able to invoke Gemini, it has to have some sort of service account identity that does that. So we're creating the connection for that, and that's all we're pretty much doing here in that step. So I'm going to go ahead and copy that here. Come over here to the new tab and create a replace model, bStery data, Gemini Flash model.
Don't forget to replace.
And again, remote with connection and replace with full connection string. So the connection string is going to be what we just echoed right here. I'm going to go ahead and copy that here, paste it here, and you're good to go.
Yay.
So essentially, we're using Gemini 2.5 Flash for this particular kind of transformation step. So now you can go to model, and you can see within the dataset, we now have a reference to the Gemini Flash model. You see when it was created, you can see the remote endpoint. So again, we're calling a model that's published by Google, and it's managed by this remote connection that we established via that command. And so now if you go to our bStery data, we now have models defined as well as the dataset or raw until content table defined. So we're building out the bStery data. If you remember the architecture of what we're building, so far what we've done is established the GCS bucket. We've created the connection between the GCS bucket and Gemini. We've already loaded via external table the GCS information via text files into the raw until content table. Now what we want to do is, after having defined the connection, we want to leverage the Gemini Flash model and convert this raw until content table into structured data. So what's our plan to do that?
Yeah, so we're using the model we just created and then use 2.5 model to transform data to structured data. So far we've done extraction, loading, and now we're getting to this transformation stage, transform stage.
Yeah, so let's take a look at the command. Create a replace table, bStery data, structure your bStery. We're calling the ML generate text command. So let's kind of learn what that does. So ML generate text, pretty much all you're doing is there's a few parameters that you specify. So ML generate text is a built-in BigQuery command that allows you to specify a model. It can be a Gemini model, or it can be some other type of model, like a self-hosted model. But for this lab, we're using Gemini. You pass in the prompt of what you want to do. So in our particular case, what we're going to be prompting Gemini to do is take unstructured text files and convert it into structured JSON. And then you can provide in other parameters such as temperature, token limits, and so on. So that's pretty much all we're doing. One thing it's important to know is when you're calling the Gemini API by itself outside of BigQuery, there's actually a way where you can actually specify JSON outputs without you having to prompt directly for it by updating the generation config within the Gemini API call. And then you can just say response output type equals JSON. But in BigQuery, there's really no way to specify that response output type equals JSON. So you have to kind of directly prompt for it. But overall, when you do prompt for it, Gemini is pretty good at giving you valid JSON. So that's what we're going to be doing here. So coming back over here to the command, essentially what we're prompting is from the following text, extract structured data into a single valid JSON object. Your output must strictly conform to the following JSON structure and data types. Do not add, remove, or change any keys. And we're telling it to extract the monster details, the battle details, the adventurer details from those unstructured text files that we kind of went through earlier. So if you recall, the text files look something like this, where you have like the adventurer, you have the adventurer ID, you have the monster, you have the monster ID, and essentially, as you can kind of see here, it's really no structure to it. But overall, you can leverage models like Gemini to essentially extract those details in a structured format. And then we're kind of giving it critical rules, such as the output format that we're looking for, raw JSON, and that's pretty much it. So let's go ahead and run that here. And also, as mentioned before, you can use a struct to pass in parameters such as temperature or max output tokens. So we're doing that here, but it's optional overall.
Yeah, basically we are using Gemini model and also prompt to using this model to convert our unstructured data to structured data. So this is our magic transformation stage, so that it can eventually analyze with this structured data. That's general. Let's see what's the structured data. What's the output?
So again, behind the scenes, it may take a little bit longer because think about what's happening.
Go to the console. You're sharing this page.
Yeah, thanks for letting me know. So I just ran that command, and behind the scenes, it took about 4 seconds, because keep in mind what's happening is that for each row of that external table, it's calling Gemini in parallel. So it may take a little bit longer than your traditional BigQuery query, but overall, it worked. And I was going to ask you, Annie, as well. So I know that here we're specifying temperature. When you're calling Gemini in general or models, do you still modify temperature, or do you oftentimes just use the default temperature? Or do you have any kind of best practices for that?
From my use case, I usually don't modify temperature. But however, I heard that some people like to modify temperature when they're doing the test. If you modify the temperature so that you reduce you're trying to make the test output to be more predictable to help with the test result. But that's just, I noticed some people do that, but I usually use the default. How about you?
Only time I modify temperature is if I'm doing like creative writing. Then I try to like bump up the temperature to like higher, closer to 1. So you get more random, more kind of innovative outputs. But for the most part, if I'm just doing traditional, emails or whatever, or just want, kind of recommendations or something, the default temperature is more than good enough. Yeah. Yeah, so great. So coming back over here, so we created the structured bestiary. We can take a look at the preview to see what the data looks like. And as you can see, that it output the JSON that we were asking for, but there are a few things that were added to it because we called Gemini. So when you call the ML generate text command, it's going to give you your output, but it's also going to give you a lot of additional metadata that you don't necessarily want. So if you take a look at the structured data that was output for each row, you see the candidates, such as average lock probabilities for each token. You can see the text that's actually what we're looking for. That's kind of embedded within the response. We can see there's other things such as the model that was called, how long it took to generate the response, the model version. So there's a lot of different metadata, such as prompt usage, candidate token count, that we don't really care about for our particular use case. So our next step is essentially going to be, how can we extract from this general JSON just the information that we're looking for, which is essentially a smaller part of the JSON that's essentially embedded within the overall JSON object. So that's our next step of the lab.
Let's see what's next.
Okay, so to do that, so we kind of walk through this right now. If you want to take a look, you can kind of see that there's additional metadata that you don't really care about. How can you essentially do cleansing now and essentially just extract the JSON output that you care about and normalize it into individual tables? To do that, here's the command that we're going to run for each different table that we care about. So if you recall, we told Gemini to output 3 different keys within a JSON: a monsters dictionary, battles dictionary, an adventurers dictionary. And now what we want to do is essentially extract that information separately and put it in its own table. So for example, what we're going to do here is parse JSON, which is a BigQuery built-in command. We're going to essentially grab the key that we care about, and we're going to then pull from that JSON those individual keys and make them their own columns within a new table. So here's how we're going to go ahead about creating a monsters table by reading those JSONs and essentially only extracting what we care about, which is the monsters information in this particular scenario. So let's go ahead and copy that here.
Don't forget to share the cloud console.
So I'm going to go ahead and paste that here. So pretty much all we're doing is extracting just the monster's details that we care about from that overall JSON that we created within that structured bestiary.
Yeah, so right now, because we already have structured data, like in a JSON format, so we can analyze them easily in BigQuery. So far we've done like we have originally have the CSV unstructured data in bucket because we load through this GCS connection and we are creating this virtual table in BigQuery, and then we are creating this model in BigQuery to transform unstructured data to structured data to this JSON format. So now we can easily analyze them and do more query, like all different type of query, right?
Exactly, yeah. So now that we can actually take a look at that monsters table that we just created, so we do monsters preview, we can actually see all the information that was extracted from that larger JSON, the monster ID, the name of the monster, the type of the monster, the hit points that's required for defeating the monster. So now that we've created a separate monsters table just of that monster's information, now we're going to do something very similar for the battles information as well as the adventurer's information. Since we know the general command, I'm not going to kind of walk through that each time, but overall, it's pretty much the same thing. We're parsing that same JSON, that larger JSON object that was created when you called Gemini. And this time we're just going to be extracting the adventurer's information. And then for the battles, we're going to be doing the same thing, but just extracting the battles information from that larger JSON. So let's go ahead and do that now. So I'm going to copy that here, come over here to the BigQuery, and then let's go ahead and create that table.
Yeah, I think again, this is like a GameFi thing. So for your real life use case, for example, you have a lot of PDF file, you want to analyze things, for example, social media analytic, you download a lot of CSV file for different analytic data, and this is like something you can follow, that you can upload them to bucket and then load them in the external table in BigQuery and query like this to analyzing, and then do more analyze and more AI stuff. And later on, you can even build like a RAG agent if you want.
Yeah. Okay, so we just created the adventurers table, and let's take a look at the preview. And we can see the adventurer ID that was extracted, the name of the adventurer, the class of the adventurer, and we're good to go. And then lastly, let's go ahead and do the same thing for the battles. And then we've now created 3 individual subtables that are essentially metadata extractions from the larger structured bestiary table that was created by calling ML generate text, just to kind of give, again, an overview of what we've just done. So let's go ahead and create that last final subtable. So creating a new tab in BigQuery, or you can just run it in the same tab that you had before in the editor. And let's go ahead and run it. Okay, so we've created the query. Let's go to the table, and let's just take a look at the information one more time. So again, battle ID, monster ID, adventurer ID, the outcome of that particular battle, and how long that battle took. So again, these are all details that we can leverage as part of our RAG agent later on to essentially give it information that it needs to understand what it takes to defeat a particular monster at a particular time. So that's just useful information that we've now kind of organized into different tables. So let's see what we can now do now that we've organized that information.
Yeah, so I saw that we organizing those data now. So what's next? What we can do with those data that we organized?
Hey, great question. Now that we've gone through the effort of organizing the data, now we can start unlocking strategic insights with this data. So think about things that you can do now that you have data organized. You can rank battles by battle time. You can figure out which monster has the highest hit points by organizing that column. And ordering that column. There's a lot you can do now that you have structured data. So let's think about a really kind of strategic insight that we would love to gather in this scenario, and think about our strategic question. So for each adventurer, what is the name of the most powerful monster by hit points they have successfully defeated, and how long did that specific victory take? So that's pretty much, that's a mouthful. And think about how long it would take to kind of get that answer without having organized the data ahead of time. So for something like this, you could maybe pass each CSV to the model, something like Gemini, one by one, and you hope that it maintains memory of past CSV files. But it would be really long because it's going to take some time to call the model, pass in the generate tokens for each CSV. But now that we've organized the data, essentially with a simple query, within milliseconds, we can get an answer to something like this, which is a pretty complex question. So let's go ahead and see how we would do it. Pretty much just by organizing the subtables that we've created, we can kind of sort by outcome equals victory. We can join tables at particular battle IDs and monster IDs. We can rank and partition the data. But now that essentially we have organized the data, we can use traditional SQL analytics to get our answer. Let's go ahead and copy this and see what our answer is. So
this is so powerful because now
Yeah.
we're basically doing all the analyzing and all having our strategy from like traditionally, like originally we have this unstructured data, and now we can do all those analyze and strategy with the structured data we already have.
Exactly. Yeah, and that's
nice.
the power of it. So let's go ahead and run it.
Yeah, I could think of that if you want to have some strategy for like, for example, social media strategy or like some research strategy, and then you can follow the similar way that we organizing the data, and then like try some SQL query like this to get more insight in from our originally like, unstructured data, right? Yeah, sorry.
Exactly. Yeah. Oh. And just like that, our output is generated, and we can actually take a look at the execution details. And in 300 milliseconds or so, we were able to get an answer to a pretty complex question that, again, without organizing data ahead of time, would have taken us a long time and a lot of token, cost to actually generate the output. So let's take a look at the results. We can see the adventurer, their class, the most powerful monster that they defeated, the hit points that was given to that foe, and the duration of the battle for that particular battle that matches that scenario. So just like that, in 300 milliseconds, we're getting an answer to a really complex question. And that's the power of, structured to structured data analytics, leveraging something like Gemini to do the transformation, leveraging something like BigQuery external tables to do the extraction and loading into something like BigQuery. That's a really powerful data warehouse.
All right, so we covered a lot in this episode. As you can see, this is an overview on the screen. This is the architecture that we covered, how to do extraction, loading, and transformation, right? So first you have this unstructured data. On the top right, we have this cloud storage. So you put your unstructured data to cloud storage, and then you're loading this data to BigQuery without actually loading the real data. You actually have the virtual pointer to the Google Cloud Storage so that you can query the data you can query things in BigQuery without loading the actual data. And then what we cover is we're creating this Gemini model in BigQuery so that we can transform all those unstructured data to structured data. And then later on, we can analyzing in the BigQuery directly. This is pretty cool because you can pretty much upload to any type of data to Google Storage, like even like audio data, image data, video data, right? Not only the file like PDF data, CSV data. So we can follow this process to analyzing them. But there's something we're missing, right? Because we're probably missing something like semantic search or RAG, right? Ayo, do you want to explain what we're missing and what we're going to cover in next episode?
Yeah, great point. So there's a lot you can do with what we covered today, essentially leveraging the power of structured data analytics against unstructured data. But there are certain questions that can't be answered, such as, tell me about a monster that paralyzes its foe, or tell me about a monster that has, fire capabilities. These are things that require semantic reasoning. And for something like that, there's what we call semantic search that we can leverage to get our insights much faster. So for tomorrow, what we're going to learn is how can we do something like RAG in context of BigQuery, where we're encoding the meaning of these text files and then doing real-time search against these text files against a particular query. So chunking, embedding, retrieval. These are all things we're going to cover as part of day 2. And we're going to build that into a RAG agent, and we're going to productionize that RAG pipeline also as part of day 2. So if you're interested, stay tuned. We'll be back soon. But until next time, keep on building, and we'll see you soon.
Yes. See you soon.
See you.
Bye.
Bye.